going on, guys? We have a question here, and it says, what is the direction? There is a current in this circuit of 0.25 amp in this figure. So they're asking us what is the direction of the current. Like as you guys see, it's gonna be counterclockwise, like this. So it's gonna go from the highest voltage to the lowest voltage. So it's gonna go on this side. And B, what is the value of resistance? So we're just gonna do the cumulative of in the circuit. And everything, the voltage equivalence should be equal to 0. So whatever that goes out from 12, it has to come back and will be equal to 0. So the equivalence, we're going to start from 12 volt minus 12 ohms minus the voltage that goes into the two resistors. So that's going to be, just to show you that the amp is equal voltage divided by resistance, and voltage is equal amp multiplied by the resistance. So here, the 12 ohms is going to be amp, that's 0.25 amp multiplied by 12 ohms, minus 0.25 multiplied by 6 ohms, okay, minus 6 volt, and minus the 0.25 but multiplied by the resistance the unknown resistance. So we have to find this one here. And everything is supposed to equal 0 volts. Okay? So if you come back, I'm just going to write it down for a better view. So the equivalence of voltage is going to equal 12 volt minus 0.25 amp multiplied by 12 ohms minus 0.25 multiplied by 6 ohms minus 6 volt minus 0.25 multiplied by resistance, the unknown resistance, and everything is supposed to equal to 0. So the voltage equivalence is equal 12 minus 0.25 multiplied by 12, that's equal to 3, minus 1.5 minus 6 minus 0.25 R equal to 0. So here everything's supposed to equal 1.5 minus 0.25 resistance equal to 0. So we're just going to take this, we're going to switch it here. So 1.5 volt equal is minus 0.25 resistance. Sorry, this one is a plus. Okay, and then we're just going to divide 1.5 divided by 0.25 equal that resistance. So the resistance will be equal 6 ohms. So this is the answer of question B. Question C, they're asking us what is the power dissipated in this resistance. So we know the power is equal, if we follow the formula, square ampere multiplied by the resistance. So now we know the amp is 0.25 square multiplied by 6 ohms, and the power dissipated is equal 0.37 watt. Okay, and then we're gonna do the voltage. We're gonna do number D. So we're gonna do number D, and they're asking us to draw a diagram. And we're gonna start from, I'm just gonna put the diagram again. I mean the figure. So there's two resistors here, and there's a battery, and there's a resistance here. So here's 6 volt, here is 6 ohms, here is 12 ohms, here is 12 voltage, and this one is 6 ohms. So what we're going to do, we know the highest voltage is 12, okay, and the lowest voltage is supposed to be 0, okay. So this one is the volt, okay, and this one is the distance. So like you guys see, it starts from 0 to 6, and then if we see the voltage on the 6 ohms, oh, by the way, we have to go clockwise. So we're gonna start with 6 voltage from 0 to 6, and then we're gonna count the voltage as in the 6 ohm resistors. So this one is going to be equal (1.5 volt), and that's 6 volt plus 1.5 volt, that's 7. So it's going to be in this side here, 7.5. And then we're going to count the voltage at the resistors 12, and that's 3. So 7.5 volt plus 3 volt, that's 10.5. So it's going to go up to 10.5. and then it's gonna go up to 12 volt, and from 12 volt we know the resistance is in the minus, so we're gonna go to the resistance 6 ohms. We're gonna find the voltage. That's minus 1.5. So 1 is here, 2 is here, so it's gonna be on this side here. So it's gonna drop all the way to 0 to 1.5. And then it's gonna go up to 0. Okay?